to do a similar simulation as we did last time, but I want to use MATLAB this time for doing the simulation. But before that, we need to make some changes. First, we need to set MATLAB as the platform for doing the code simulation. So what you do is you need to go to the utilities and customer default. Here you go down to the simulation analysis, and then you find the MATLAB executable file. You set the executable file here and then click OK. Remember that you need to restart NX for it to take the effect. To fix a stupid default setting, so you go to the motion preferences, and here you put this on ignore units. This way the software won't check for units every time you want to define a condition. So this is our last simulation, which we did in NX. Now I want to do the similar thing with MATLAB. Find two signals to drive this robot. The first signal was using the sensor, which is checking the distance to be less than 300, then sets the signal to -1. The next one sets by a 4-second delay. So we have another signal which was always -1. We need to generate these two signals, but by using MATLAB. First, I need to deactivate these two signals because we're not going to use them anymore. Also, I'm going to remove the DC motor that we defined. Then I'm going to change the drivers to use functions instead of signal charts. And then I will connect these functions to MATLAB. I want to control velocity, so I put it on velocity. Then I define a new function. Here I click new function. I just write 1 in the formula for now, but I will change it later. Add another function since I'm here. And I have two functions, and I will change it later. Now the function signal 1 is driving the driver 1, and function signal 2 is driving driver 2, which are driving M1 and M2. To connect these two functions to MATLAB, we need to define inputs and outputs. So we need to define input, plant input and out. But here is grayed out. I need to go back to the environment where we need to change the setting. So you check the code simulation, and now you can go back to insert, and we start by defining inputs. Then we connect these inputs to functions, and we connect outputs to sensors. So this way MATLAB can communicate with NX. I named them as the name of the motors and click OK. Now we can set up the MATLAB side. So I'm going to run MATLAB. But since I have the inputs, I can actually change the functions to read the inputs instead of the one that I have here. So I'm going to remove that, and instead I assign the M1 input, for example, and M2 input. This way this function will be set by using the inputs, and inputs are going to be set by MATLAB. So this way we can drive M1 and M2 by using MATLAB. We need to run Simulink to set up a template file. The NX needs a template file. You can also click on the Simulink to run it. Simulink is basically a block coding system. There is almost no place to write codes. This is going to be my template. I name it NX3. You don't need to add anything to it. It's just a template for now. We are going to add components and blocks later. Make sure you use MDL file because that's what NX is reading. We can now close MATLAB and go back to NX. Here in the solution I will set the same file that I made, the template file, in the NX. So the NX is using the same template file, and it says I need to run the setup again to integrate Simulink with NX. This integration will set up the parameters between MATLAB and NX. For example, it will set the time and frequency of the communication between MATLAB and NX. So now the MATLAB is being run by the NX to set up for the integration. You need to wait a little bit. If you check the status bar, you see it is initializing. It's trying to set up something that is called S-function block. It is being made by NX, so we can use this block in our Simulink blocks. As you can see, it is made based on the model we already have. It has 2 inputs and 1 output. And note here that it says NX host. If it's not host, you need to change. Here I'm going to add 2 blocks. I need 2 constants to drive the motors. As you can see here, each input is 1 motor, so I need 2 constants, 2 numbers to assign to these inputs. These inputs are going to be the functions we defined in NX, and those functions are going to be velocities of the joints. I'm going to set the velocities on 2000. This is radian per second. If you click on the model, you will see the same thing that we defined in NX. So I go back, and also I have an output. Instead of adding the block, you can just write directly in Simulink, and I will open it for you. So I will write a scope, and I just put a scope to read the sensor that is measuring distance. I connect the inputs and outputs to the motion plant block and save it. Now you can see we have 3 M files that are necessary for running MATLAB, and in total 5 files, with it, including a template we made in the beginning. That template is not going to be used for anything. It's just a template to set up and integrate MATLAB with NX. I'm going to close MATLAB, and for the first run I'll try to make the NX host. So I start with run from NX. The NX opens MATLAB and acts as a host. Here NX is sending messages to MATLAB. MATLAB is reading. So it starts the Simulink file that we made and runs the simulation, and then closes the MATLAB. It is initializing now. If we go back, you see that it is running the simulation by using the Simulink file that we made. Now a better option is to run the simulation from MATLAB side. This way NX is going to be the client and MATLAB is going to be the host. Here you see that one of the M files that we saw in the beginning is missing. So we need to go back to NX, and here if I go and set the solve option on Simulink as a host program, it will generate the M file we need here. By using this M file, we can actually run NX as a client and use MATLAB Simulink as a host. Going to remove the comment of this line to load the parameters that we need for the simulation and run the M file. After the client is running, it will generate a new kind of block, which is NX client this time. Remember that last time it was NX host, but now we have NX client block. So I'm going to remove the NX host, which is being used when NX is being host, but now we need NX client. I save this file and we can close this one and continue running from MATLAB. If I run the simulation from Simulink, you see that it will start to run the simulation in MATLAB and transfer the result to the NX. Now this method is making it much more easier to change parameters and see the effects than running the NX as a host, because as a client I can easily change these numbers here and just run the MATLAB, and I can check the results right away. It actually starts the simulation after this warning, so you need to wait a little bit after you click on the play or running the simulation, because it takes a while for Simulink to communicate with NX and read the parameters and write the parameters. A good thing about this type of simulation is that you can actually go back to NX and keep working on your model or check the simulation and other stuff while you're actually running the simulation. I can also check the results without going back to NX. I have this scope here, so I can click on the scope and read the sensor, which is the distance of the sensors and markers in the simulation. Now that we have a good result, I can start changing the signal a little bit. We want to stop the robot from falling off, so when it gets close to the edge, we want the signal to be negative. Output threshold as we had before. If it's less than 300, I want the switch to activate and change the direction of the motor. I just copy and paste this block to make a new constant as a feed to the switch. So when the sensor is more than 300, it will switch from 30 to -30. The result is not bad, but I need to increase the time of the simulation, and also we can fix the names to make it easier to read for everyone else. If I click on the block diagram, you can go inside and you see something like this. Then I can change the time step by clicking on the red block and also increase the time of the simulation.